Hello, I'm Professor Sunchul Kim, Department of Biomedical Engineering, Keimyung University. This study is a study on the radiation shielding performance of shielding fibers woven using industrial tungsten wire. Due to the recent increase in the amount of medical radiation used by medical institutions, radiation exposure in the diagnostic area is increasing. Most of the radiation that is a problem in medical institutions is caused by indirect radiation rather than direct radiation and generally means scattered radiation. Scattered radiation corresponds to a low dose and means a dose of less than 100 millisievert of low-dose radiation. In this study, the lining of radiation shielding clothing that can protect from indirect dose was developed. Most of the shielding clothing linings are in the form of sheets and they can easily get tired due to their heavy weight. In this study, it was intended to be made in lightweight fiber form using tungsten and eco-friendly shielding material. Tungsten is an eco-friendly shielding material with a high density of about 20 and has been usefully used as a substitute for lead in various recent studies. Tungsten wire on industrial filament was used as the main material, and a shielding fiber was manufactured using this as a yarn. Radiation shielding sheets currently used in medical institutions are manufactured based on lead sheets. However, in the case of lead shielding clothing, there is a problem in that activity is reduced due to the heavy weight. In general, apron, which corresponds to 0.5 millimeter of lead equivalent, weighs about 3 kg. Also, since apron is shielded from shoulder to knee, wearing it for a long time can put a strain on the body. Therefore, in recent years, a lot of research to develop a light and thin sheet is in progress. In addition, a lot of research has been done to develop a lightweight sheet using an eco-friendly shielding material in recent years due to the problem of environmental pollution. Lightweight sheets can be made from eco-friendly materials such as barium sulfate and bismuth oxide, but in this study, we made fibers using tungsten wire for the purpose of improving durability such as tensile strength. The tungsten yarn used for the production of the shielding fiber has a diameter of 50 micrometer and it was selected in consideration of strength during weaving while maintaining the flexibility of the fabric. Since this weaving method reduces the voids between the yarns through the multi-layer structure, high-density weaving is possible. In addition, it has a structure that can be double-coated with the shielding material in the future. And therefore, it is possible to control the shielding performance by using a laminated structure or a double coating according to the radiation energy used in a medical institution. The shielding performance test was conducted as shown in the figure. In order to test the shielding performance of tungsten fibers, the Korean industry standard lead equivalent test method was applied. In addition, the tube voltage was set sequentially from low energy to high energy used in medical institutions. It was measured with an X-ray generator and a dose detector, and the shielding efficiency was calculated using the following equation. The thickness of the fabricated shielding fiber was about 0.20 mm. Fibers manufactured in the form of mesh can maintain a certain shape during processing, and because of their very thin thickness, they can be used in a laminated form depending on the radiation intensity in the future. In addition, there is an advantage that the shielding performance can be controlled because the shielding material can be double-coated. Such a structure may improve tensile strength and increase durability. Therefore, it can be expected that it will be much lighter and more active than when a shielding sheet is made based on the shielding sheet. The shielding test results are as follows. As a result, the fabricated shielding fiber exhibited a shielding performance of 12%. It was found that the shielding performance was improved by about 5% in the high energy region when weaving at a high density in the form of a mesh compared to the conventional single weaving method. This result can be expected to be caused by the fact that when a single weaving method is applied, voids are formed between the yarns, but when woven in a mesh form, the voids are reduced due to a multi-layer structure. In this study, tungsten wire was used as a yarn to fabricate a shielding fiber that can be used as a lining for shielding clothing. These fibers were woven at a high density using a mesh weaving method. As a result of the shielding performance test, it was found that there was a 5% improvement effect compared to the existing weaving method in the high energy area. This result is expected because the voids between the yarns can be reduced when weaving in the form of a mesh. The mesh tie weaving method not only enables weaving in a multi-layered structure, but also enables double coating of the shielding material. In addition, it can be used as a laminate according to the radiation intensity in the future, so it has the advantage of easy control of the shielding performance. In addition, it shows flexibility and strength similar to general fibers and is considered to be useful as a material for low-dose shielding clothing in medical institutions. Thanks for listening my presentation.